We'll talk about it. Okay, so we're adding and subtracting rational expressions today. Just like on the previous lesson, I'm going to go ahead and do just a numerical example so you can kind of see what I'm talking about, and then we will get into examples that have variables in them. So the example that we're going to look at is asking us to add 4/9 and 5/6 together. I can't do that.
Oh, come on now.
No. I can't do this right now. I mentally can't do this.
Okay, can I add them the way that they are?
No.
No. So what I'm going to do is I'm going to break them down until the denominators are in what we call factored form. And then I'm going to see what they have in common and what I need to put into each of them so they have the same denominator. So I know that I can break 9 down into 4 over 3 times 3, right? Because 3 times 3 is 9. Yes. And then I know 6 is 2 times 3. So then this is where I can now create a common denominator. What do these two denominators have in common, if anything?
3.
They each have a 3. So that 3 is already present in both of them, so I don't need to put it in. What is this denominator missing that this denominator has? This one right here. It's missing a 2. So I need to put a 2 into this one so that I can later combine it with this one. What I do to the bottom, I also have to do to the top. So I need to put a 2 into the top and the bottom of my first fraction. Now, each of these denominators has a 2 in it. Yes, Shane?
That's 2 times 3.
Yes.
Okay.
Multiplies in. Is there anything that is present in my first denominator that's not present in my second denominator now? A 3. So I need to put a 3 in here so that my denominators are identical.
Oh, I see what you're doing now.
Now they are the same, which means I can simplify them and put them together as one fraction. So these I simplify by just multiplying together. 2 times 4 becomes 8. 2 times 3 times 3 becomes 18. Plus 5 times 3 becomes 15. And 2 times 3 times 3 again becomes 18. I notice that both denominators are 18, which is what I wanted, which allows me to rewrite it as one fraction with that common denominator present. And then I simplify the numerator as far as I can, which becomes 23 over 18. So we added these two fractions by creating a common denominator and then simplifying the numerator. That's what we're doing today, but instead of nice pretty numbers, we're going to have some variables.
We're gonna have things that are fake. Is that calculated?
Huh?
Not this fake. X does not equal number. It equals letter.
Yes,
Is
Dan.
that just how we leave it?
Yeah, that's how you would leave this one. Yes.
I'm changing how you do long division.
Oh my god.
They are.
No. It's disgusting.
Yeah, a lot of the new stuff is gross.
A lot
Okay.
of the old stuff is gross too.
Are we ready?
Yes.
Yeah.
Good old sex and
Don't stop.
I actually
think
really
it's-
liked Saxon math when I had it. It's Common Core stuff that's changing.
Yeah, Common Core sucks. It told us that like 2 plus 2 is 5.
I'd much rather.
Literally in the book said 2 plus 2 is 5.
Yeah. It did. I don't remember how they got it, but it did.
That's what the book said.
It's because 2 divided by 2 is 1, so then you have 1 and 2 twos, and then you add all that.
Oh yeah, that makes sense.
That's what it is.
Because it's not even addition anymore.
We could just spend all of math class talking about the differences between stacks.
We could. That would be good.
That would be a good essay.
No.
Why would
Okay, so the example I now have in front of me has the first fraction being 3y over 2x cubed, plus the second fraction, which is 5z over 8xy squared. I will caution you to be careful with your z's because they can very easily turn into 2's. So that's why I always put a dash in my z so I know that they're different if I'm writing it really quickly. Okay, I can do that too.
Kendra, you just can't write.
So when I'm given something like this, it is often helpful to break everything down as far as I can, or until it matches something in the other denominator. So on this one, I'm gonna rewrite the second denominator, breaking 8 into 2 and 4, and then we're gonna see what we need to add in to make them be the same. I'm leaving space in front of this fraction and after this fraction for a reason. I suggest you do as well. So the only difference between what we initially wrote and what I just wrote is that I broke 8 up into 2 and 4. Why would I break 8 up into 2 and 4?
Cancel.
Because then I notice that there's already a 2 in the first denominator. So I already have one thing that's present in both, which means I don't have to put another 2 into that left side. Is there anything else that's the same between my denominators?
I mean, there's only one X.
Some X's, yes. There's not the same number, so I'm definitely going to be putting some X's in, but it's nice to see the similarities. Okay? Everybody have this written so we can get started. Oh. Yes. You could, but that doesn't help me any more than 2 times 4 does. Because there's only 1 2 present in the first one, so I only needed to match 1 2. But yes, you absolutely could have done that. Okay, so on this one, I need to make what's here match what's here. So I already have an X over here, so that one's okay. But what else is this denominator over here missing? It's missing how many Y's? 2, so I'm definitely going to be putting a Y squared in over here. What I do to the bottom, I also have to do to the top. What else am I missing? A 4. Because this has a 4, but this one doesn't. So I'm also going to be putting a 4 into this side. So I'm multiplying 4y squared into both the top and the bottom of that first fraction. I'm going to repeat this process then with this side, and then we will multiply it out and simplify. So what am I missing from this second fraction that needs to be present to combine my denominators? X squared. Anything else? No. My y's matched. The 2 was present over there. The 4 I put over there. The X is good. Well, the one singular X. So I just need to make it an X3. So I just need an X squared on both sides. Remember, whatever I add in is multiplying into the top and the bottom of its respective fraction. And so that's what I'm going to do in my next step, is just put it all together. So the green combined with this initial first fraction, I put the whole numbers together to get 12. And my y's combined to become y cubed. I go ahead and do the same thing in my denominator, and I should get 8x cubed y squared. I do the same thing with my second set of fractions. And I get 5x squared z over 8x cubed y squared. I'm going to pause here just so you can see how that worked out. And then we'll finish simplifying. It's a 2-day lesson. Huh?
This is already pretty like.
I don't really think it gets worse, except we do subtraction instead of addition. I don't really think it gets any worse.
It's just subtraction.
Addition and subtraction. Yeah.
Oh,
I believe so, yes.
okay.
Okay, anybody confused by what we did? So essentially we multiplied things in to create common denominators, and then we'll just finish simplifying. Did anybody not get these 2 fractions? Now how do I finish out this problem? Put the numerators together and write it as one singular fraction. So this becomes 12y cubed plus 5x squared z over my common denominator of 8x cubed y squared. There's nothing that simplifies, so that is my final answer. Yes, ma'am.
So you can't combine the 12 and 5 because they're connected to different variables.
Correct.
But if they were,
If they were identical variables with identical exponents, yes. How do we feel about that problem?
Are we about to do like the chart and stuff again?
No. Not on this one. How do we feel? Okay? Not okay? Not terrible? Let's do another one.
Don't smile. It's not a good.
So my first fraction is 4 over 5a cubed b squared plus 9c over 10ab. What's my first step here? Break down what I can in the denominator so we can see what we need to add in order to make them match. This is not a required step. If you can see it without having to do that, that's fine. I'm going to do it though, just in case anybody has a question. So I'm going to leave space in front of my first fraction and after my second fraction, so we can go ahead and put in the stuff that we're adding in, but I'm going to go ahead and break them down. So the first fraction is going to stay the same. The second fraction, I'm going to break down the 10 into 2 and 5. And then we're going to see what we need to add in. What do I need to add into the first denominator in order to make it match the second denominator? Do I need anything else? I already have an A and a B, and these are bigger than these, so there's no way of making those smaller, so I can't do anything with them. So I just need the 2. What I do to the top, I also have to do to the bottom. And then we're going to look on the other side. So Sam, on the other side, what am I going to need? Just 1 or what? 2 A's and 1 B. How do I know that I need 2 A's? Because it's A3 here, and I only have 1, so I need 2 more. And I need another B because this is B squared, and this is only a singular B. So I'm going to multiply A squared B into both the top and the bottom. Then we just multiply it in, and we'll simplify and put it together. Oh, I don't know what happened to that. I really think it is. It was lagging this morning too. I like moved it and it'd wait a couple seconds and then it'd move. So I end up with 8 over 10 a cubed b squared plus 9a squared bc over 10a cubed b squared. Questions or concerns so far? Do we all see how we got that? What do I do next?
You just combine them.
Put them together with this operation and then write them over the same denominator. So this becomes 8 plus 9a squared bc over 10a cubed b squared. And from here, I would look to see if there's anything I could reduce, and there's not, so I'm good.
That'll be it.
That'll be it. Is this getting any easier?
I think so.
No,
Start getting the groove.
it only goes to the fraction. I don't wanna say anything else, all I know is it goes to.
I get half the time, you're the one who changes it. So
Okay, are we all done writing example B? Yeah, okay, I'm gonna give you one to do on your own. And then we will kind of move on a little bit.
Hooray.
Only difference between the one I just gave you and the one we just did is that this one is subtraction instead of addition. So in the final step, I will subtract the second numerator from the first.
You can break it
How
down.
do we break that down?
It's not.
You should like at least done B on
After show me that level, like,
Yeah, so if they have nothing in common, then you just have to multiply the whole number from the right into the left and the whole number from the left into the right. It's the only way to make them the same. So this one, you're gonna have to multiply by 16 in the top and bottom, and this one you'll have to multiply by 5 in the top and bottom. It's the only way to make them the same if they share no common factors.
how much?
What makes me so sad is 80.
Thank you. It's 80, yeah.
We're in
I
algebra
can't do
two.
math.
We worked for.
I shouldn't be here.
We worked through algebra 1 for the privilege of the piano. Yeah.
Compton used to give me only addition and subtraction problems because he knew I couldn't do those.
So I'm gonna give you nothing but just addition and subtraction you can't do.
No. That's evil, Miss Julian. That
Is it evil or strategic to make her remember them?
evil. I think it's.
You'll just make her
Yeah,
cry. I think it's
people
strategic.
have-
Make me cry.
I've already had people sob in here today. A little crying is not gonna change.
Durant, that's not something to brag about.
I'm not bragging. It's a mistake and a fact.
128.
Oh my God.
I love this.
16
I'm
times
still
5.
hurting my head.
80. Hey, who would like to tell me what we're gonna put into that left-hand side to make the denominators the same? Raise your hand. What am I multiplying in them?
5A.
Just 5a or
Oh, I didn't see that.
5a cubed? Perfect.
Oh my gosh.
What about on the right-hand side, somebody from this half of the room?
Okay.
Yeah, geez.
Somebody from over here. Delilah over. What are we doing? Just a b? 16b, because I need to make this 16 be present over here so I can combine it. But yes, the b definitely needs to be here. So then I go ahead and I multiply all of it in. And when I do, I'm going to get 15a to the 5th over 80a cubed b squared minus 128 bx over 80 a cubed b squared.
Wait, where's the? It's 128. 128.
16 times 8 is fine.
60. Oh my God.
I'm okay.
Why did I?
Okay, all I did was put them together.
Is this?
Well,
Oh,
yes,
you
no,
put them on
no,
the
you have
top.
to put all pieces in.
Yeah, I'm maybe. Maybe.
Are we gonna eventually factor these?
No, not trying to factor these.
Or, yeah, no.
Do we all see what I did here?
No, I'm lost.
Can we say no?
Okay, are you trying to work through it or are you just staring at it saying you're lost? Because there's a big difference.
No, no, I'm trying to work.
Okay, as long as you're trying to work through it, what do you need me to go over?
Okay, so on the first part where you're trying to break it down,
Uh-huh.
you just add the 5.
I put the 5 in because there's nothing I could break 16 down into that would have a factor of 5 in it.
Oh, so that's.
So
what-
since they didn't share anything, I just had to put the whole numbers on each side
Okay. So
Yeah.
you just did opposite.
Yes.
That's where I was.
to create those to be the same. Yes, Madison.
What happens if you did break down the 16 into 8 and 2?
You would still have to multiply 8 and 2 over to the other side.
Would
It-
it still work out?
Yeah, yeah, because 8 and 2 is still just 16. You just did it in a spread out form. That's all. Yeah, it'll still work the same. Yes. You have a question? No? You're just, okay, just checking. Everybody else see what we did? So then what's our last step, Christina? Put them together. How am I going to put them together? Yeah, am I putting the numerators together? Am I like subtracting the denominators too? Or is it just the numerators that we perform the operation on? Just the numerators. So then this becomes 15a to the 5th minus 128 bx over 80a cubed b squared. Yes, ma'am.
So I did negative 100. But they don't have the same variable.
Correct. They do not have the identical variables, so I can't combine them. How do we feel about this one?
It's like easy, but at the same time, it's not.
Yes, Reese.
Oh, no.
Oh, you're okay.
Mr. Aaron, is there another part?
I don't really think there's another part. There's just different ways of looking at the same type of problem. Huh? No, I'm not trying to. Okay, let's go ahead and do a different one. Maybe give your brains kind of a break from this. And let's start looking at ones that have quadratics that can be factored, and we can go from there.
You had to say something about that.
I mentioned this is
You had to say something about factor.
I refactoring.
I was surprised. And I've been about to cry since you put it up on the board. If you make me cry, random
I make no promises.
Are we just adding or no twist? No twist.
No twist. We're doing the exact same thing, but this time we're doing it with factors instead of just variables.
No.
Exact same concept. And the best part is I'm just going to tell you what the factors are so we don't take the time to actually find them. But you should be definitely practicing that on your own time.
Oh, I do, that's all I do on my own.
Oh, I bet it is.
I only do that. I usually just practice.
Yeah, I definitely practice.
When I get home, I factor. That's my first step.
Okay, so just like on the previous problems, I'm going to break the denominators down. But instead of just finding like multiple numbers that create a number, we're going to look at factors that create a quadratic. So these are going to factor out the same way, or I'm going to pull out a common factor. I'm going to break it down to see what they have in common, and I'm going to insert whatever they need to be the same. So rewriting this, I have 5 over, I'm going to pull a 6 out of both of these and put it out front because maybe x minus 3 is going to be something that will be in common. So this becomes 6 times x minus 3 plus x minus 1 over. This is going to factor into 2 out in front of the parentheses, and then 2x minus 1 times x minus 3. I factored it out into what it was before I FOILed and created the square. You make me very concerned about factoring now.
Oh, we're doing the same thing that we did yesterday.
Yeah, same thing we did
So
yesterday.
It's not bad factoring, you're just throwing. Okay.
Yeah, it's just quadratic factoring. Okay. Does everybody see what I did
Yeah.
for the most part?
No. Go back.
The concept still works the same way. Do my denominators have anything in common right now? X minus 3, which means this doesn't need to be added to either side because it's already there. But everything that they don't have in common is going to have to go to the opposite side. So what am I going to have to multiply into this left-hand side? 2 and a 2x minus 1. Into the top and the bottom. What's going to have to get multiplied into the right-hand side? 6. And then we just put it together, Sam.
It's 4x.
I pulled a 2 out. So I took a 2 out of all of these and turned it into 2 times 2x squared minus 7x plus 3. And then that's how I created the 2x minus 1 and the x minus 3.
Wait,
Oh,
Wait,
that's why
now I'm
was trying to figure out how to do that.
What are you confused on? Don't worry about this. This is something we can go over later. I'm telling you this became this. I'm working on the process of this right now. I'm more than happy to go over factoring later if that's what you guys need.
I didn't know what
Yeah, sorry.
2.
Okay, so then I'm gonna do exactly what I did before. I'm gonna multiply those new additions into each side. And I'm gonna simplify it and rewrite it as one fraction. So on the left, I'm gonna put my whole numbers together. So the 5 and the 2 become 10. And the 2x minus 1 just stays. Over, the 2 and the 6 become 12. And I'm left with 2x minus 1, x minus 3. So that was all just that first fraction and what it became after the new additions.
Do it twice. 2 times 2x minus 1 and that times 5. Or are you still gonna?
Yeah, this was just the first fraction. I haven't done the other part yet. And then plus, I'm going to do the same thing over here, multiplying this 6 into both the top and the bottom. So it becomes 6 times x minus 1 over the 6 and the 2 combined to become 12. And I still have 2x minus 1, x minus 3 in the denominator. And then I just finished by putting my numerators together. And we're gonna leave it, no, we're not gonna leave it, we'll combine it. I think it's more fun. So I have 10 times 2x minus 1 plus 6 times x minus 1 over common denominator, 12, 2x minus 1, x minus 3. Yes. Yeah, I'm gonna pull it up. Yes.
Can you show me the factoring like process? Cause I
Not right now, but later, yeah. I don't want to intercept like what we're doing right now for that.
I forgot how to do
Yes, ma'am.
it. If you put separate, like, is that wrong or should-
If you kept them like this?
Yeah.
Yes, this is wrong because simplified is one singular fraction. Yeah. On these, however, we are not finished. We are finished once we've distributed any whole numbers into their respective parentheses and combined like terms. We actually made a mistake on this one, and it's a mistake that's okay to make because we can correct it here. What mistake did we make?
We never make
That's not true at all. Math is all about mistakes. What mistake did we make here? Wasn't there already a 2 on the left-hand side? It was just disguised as a 6, which is 2 times 3.
No way.
So technically, I already had a 2 over here. If you don't notice it, it doesn't change anything. Just when you get here, we should simplify before we start distributing. I noticed this mistake because this is a 10, this is a 6, and that's a 12, and those are all divisible by 2. So I can reduce those before I continue to simplify. It's okay if we put too much stuff in. because we can always simplify it out here. So that's what I'm gonna do before I start distributing. I'm gonna take a 2 out of all 3 of those whole numbers. I can do that because all of them are being multiplied into all of my terms. So then this becomes 5 times 2x minus 1 plus 3 times x minus 1 over 6 times 2x minus 1 times x minus 3. And now I'm going to distribute the 5 and distribute the 3 and combine like terms. And you should end up with 13x minus 8 in the numerator over 6 times 2x minus 1 times x minus 1 in the denominator. It's not going to change anything. We really, excuse me, we really only simplify and distribute the numerator. It's fine to leave that denominator factored like that.
So you can leave it like that?
In the denominator, yes. In the numerator, no. I expect you to distribute in the numerator. How do we feel about this one? Yes, Kenya.
Why did that x minus 3 change to an x minus 1?
Oh, it's just x minus 3. I just wrote it wrong. Sorry. Sorry, looking at too many numbers. How do we feel so far? Was that the worst thing? Was it close? Maybe. Maybe, okay.
So if we were to distribute the 6 in the denominator, would it be wrong?
I wouldn't count you wrong, but that's a lot of unnecessary work. Yeah. Because I would have noticed if anything was going to simplify. That's just really practice for you. Okay, so we are going to do another one. I will tell you, I think this one's a little bit nicer than the last one. Like half as much work. About maybe. So this is example B from this section. And it is x minus 1 over x squared minus x minus 6 minus 4 over 5x plus 10. Of course, I know that I'm going to break down my denominators and then see what I have to multiply into both sides to make them the same. We are going to factor this one because it is a quadratic, and I can tell you that all of the quadratics that I give you are going to factor nicely. So if I'm looking at this one, I'm looking for 2 numbers that multiply together to get -6 and add to get -1. -3 and +2, yes. So when I break this denominator down, that's what's going to break down into. What about that second denominator? It's not a quadratic, so I'm not just generic factoring. But can I break that down any farther? Take out what? 5, yeah. And I get 5 times x plus 2. This is desirable because then they will have a common element. So writing this out, I have x minus 1 over x minus 3, x plus 2, minus 4 over 5 times x plus 2. Never leave enough room. I'm going to look on the left first. What is present in that right denominator that I need to make present on the left? Just a 5, yes? So I'm going to multiply a 5 into the top and the bottom. What is present on the left that is not present on the right? X minus 3, so that's what I'm going to multiply in. That was a terrible sound. I go ahead and I multiply it in. I end up with 5x minus 5 over 5 times all of that stuff. Minus 4x plus 12. No, it would be plus. When I distribute the 4 in, it's going to become 4x minus 12, but it's minus. So that negative has to distribute. That is another huge mistake I see happen all the time. This subtraction acts like a negative that has to distribute to the terms inside of that second term. So that's why it became minus 4x plus 12. Sorry, what? Yeah, technically it is minus 4x and then plus 12, but we just leave it as a subtraction, but it means the same thing. And now what can I do? What can I do?
You just,
Put them together. When I put them together, what else am I doing in the numerator? Combining like terms. Yes. So I have a 5x and a minus 4x, which makes a positive 1x. I have a negative 5 plus 12, which makes a positive 7, over their common denominator. And I will pause.
Minus 12.
really quick question.
No, because this is the same as that.
A little bit.
Plus negative.
Yeah, so it's 5x minus 4x, and then negative 5 plus 12. I already changed the signs. Here. Yeah, I already changed the sign. If you wanted to wait till right there to change them, that's fine as well. I choose to do it early on. Yes, Shane.
So that actually the x squared becomes x plus 2.
The x squared became the 2x's that I split up into these two factors. So if I FOILed these back out, x times x would make x squared. No different than taking 10 and breaking it down into 2 and 5, because when I multiply them back together, they still become 10.
Because when I see the x minus 3, I see it from like negative, well, the x minus 6. That's how you do that. I don't know.
Okay, so it sounds like you need practice factoring. Because what we did is we unfoiled. So we're so used to going from this and turning it into this that sometimes we forget that we went like something this complicated once looked like these two simple factors. So you need to practice foiling and unfoiling, so factoring. Okay, I suggest you do that as well as your homework. Okay, I'm gonna stop here because I feel like this might have blown your brains.
What's that?
Oh, now I understand.
And then we will do some more examples tomorrow, but you should be able to do a good chunk of your homework.
I should be able to.